Good morning, everyone. Thanks for being here. Well, Steve Vega, you gave a great intro to my talk, and I don't have to explain too much, but let me progress forward. Oh, okay. Hi, Amy. Figure out what button to push here. Okay, let's go over here. So I want to thank partners. I work in 2 different states on these projects. In Colorado, I'm just looking at who my partners are that are in the room. Cinnamon Levi Flynn in the back there works with Colorado. She's my project champion and manager. And then Brian Router with CDOT as well is another project manager. And then with UDOT, Kevin Nichols was here, but he is gone. I also work with Todd Black of Eagle Mountain. And then I work a lot with Tim Hazelhurst of Crosstech, who's sitting in the middle of the audience. So he may help you with some questions. First, I'll tell you more about Eagle Mountain, where we do our work in Utah, and then I'll talk about Colorado State Highway 13, and then I'll wrap it up with some recommendations. This work is really complicated, as Steve said, so I'm going to probably generate a lot of questions because I'm not able to go into great detail. But anyway, Eagle Mountain, south of Salt Lake City, it's a rapidly developing city that is trying to figure out how to continue wildlife migrations, particularly mule deer from the north and south, where that yellow line is back there. And so it's a really tough situation. It's a no-win for the mule deer, so we're trying to figure a way to get them from their winter and summer habitats through a maze of human development. They have, Eagle Mountain and UDOT work together on State Road 73 to put in a crosswalk, which is kind of unusual. It's experimental to some degree until we get an underpass. But right now, it's 60 feet wide in this highway with miles of fence on either end. The system that Crosscheck put in there uses thermal cameras. That's a key part of my talk, is what's used to detect the wildlife. So the thermal cameras are used to detect wildlife approaching the crosswalk and warn the drivers by activating the system with lights, amber lights, and slow down signs. So if you look at this particular sign right here, these line up for both directions of highway. We put in reconics cameras to see what the animals are doing and when they're there, and then we actually have radar detection data loggers of when people are coming through and looking at their speeds. So we're trying to evaluate the system very quantitatively, but the objective, my project champion in here is the traffic safety engineer. So I got to look at what people are doing more than what the wildlife are doing, but we love what wildlife are doing. So I wanted to show you this beautiful picture. So in about 15 months of monitoring, we've got 1257 successful mule deer movements across the highway, but the success rate is only 55%. And there's so many people. Our data loggers show 10,000 vehicles a day. This is so hard. They only cross at night now. There's very little crossing during the day. So the system that's there with the thermal imaging cameras, from what we could see, we don't test it directly. We test it indirectly by looking at the light shine of the warning lights on the ground and the deer as they're moving through. And over 1,500 times the animals were there, 94% of the time, those thermal imaging cameras and the system worked correctly and warned the driver. So the bottom line, I put red highlights here because I'm going to throw so much at you. System is working at a high level of accuracy. And so we looked at the driver's speeds. I have to touch this. I apologize. We have controls outside of the drive area where the wildlife are, and also these are controlled data loggers of the speed, and then one in the crosswalk. And you can see what's real tricky is a lot of people, the speed limit is 55 miles an hour on the east and 65 miles an hour on the west. And there's a lot of complexities, but you can see that people are going over the speed limit in the wildlife crosswalk on average. So it's kind of tricky. There's a lot of people moving in from urban areas that don't know they're supposed to slow down. Last week we walked and we did an experiment where our data was showing people were slowing down at night when the lights were on and the deer were there. But we didn't know, were they slowing down because they saw the deer or because the lights were on? It's very technical stuff. So we did experiments where we walked out and just put the lights on and then snuck back behind the fence. And the yellow that you see there, you can hardly see it in the back, so let me read it for you. Oh, you're the shocker. People slow down an average of 2.8 miles per hour. And it was statistically significant, but we're not getting maybe what we wanted. So when the lights are on are the yellow arrows, and they were down to 56.2 in the crosswalk. And when there are no lights on, they were 59. So we got them down just a little, and it's very consistent with the, excuse me, with the literature. Now let's go to Colorado State Highway 13. This Craig study is up in the northwest corner of Colorado. And this is a tricky situation. You can talk to Cinnamon as to why they put all the different kinds of mitigation measures they did there. But there's a driver warning system there over a half mile. So we went from 60 feet to a half mile. And we don't have enough time to tell you all about that, but the driver warning system is very similar in what the people see, but this one uses radar because it's such a long distance. If you look at that, you've got a long distance for all these cameras and detectors to figure out where wildlife are moving through. So the radar feeds the information in, and we wanted to look at motorist speed changes and how it functions. I look at historical information on cameras that Tim has placed in there, and this gives you an example. When an animal crosses the road, people see those lights. We put all the time that the animals were in the roadway in the sampling that we did and how often the lights were on. And a couple of months ago, it was only 57%, but now we're working together to get it much more accurate. So to wrap up with recommendations, when you have a more restricted area, thermal imaging cameras work really well. Of course, you need a 2-lane highway, et cetera. In the future, if we can link thermal and radar together, you can get those longer distances and you can get it more accurate. So in summary, if you want more information, we have reports on these two projects on my website, Wildlife Connectivity Institute, and we upload the quarterly and annual reports every year, so you could every couple of months, so you can keep up with us. Thank you. Speed differences there as well? Yes, we did the speed. The question was, did we do the monitoring speed in Colorado? Yes. This is a highly technical thing, and we didn't like the data that we were getting from the speed detectors there, so we're keep tweaking them and moving them around to get it right. But people are coming in like as much as 75 miles an hour, and even if we're slowing them down a little, we're still only getting into the 60 mile an hour range, which is not all that great. But yeah, stay tuned. We'll tell you more. Right. I was curious how much advance notice of lights and signs of possible signs say, be prepared to stop. It just says slow down at this point, but because I went through so fast, I knew there'd be questions. There's signs before people get to these areas to tell them wildlife on the road, be careful, but we could improve our communication with humans is the sociology part that explains it a little bit better. But right now, the flashing white LED lights just say slow down. I know there's more questions, but the next 7 minutes, the next person. Okay, thank you. Thank you.